Hello, I'm I present my
Hold on a
presentation,
second.
your robot.
Hold on a second. Hi. Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo. And today we have, you probably heard him already, we have one of our students, Marcos, who has prepared the presentation, ROS Basics in 5 days. And that's what we're going to be seeing here today. So hello, Marcos. How are you?
Hello, I'm fine.
Awesome. It's great to hear. So yes, whenever you can please share your screen and show us what you've done with your video, with your
Okay,
presentation.
I will. Can you see my screen?
Yes, we can.
Okay, can I start?
Absolutely.
Okay, so I will show you the real robot, and then I will show the codes, the nodes I make it. Um, so I will start with the following well. Um, so let's start. The robot will find the shortest distance,
Mm-hmm.
wait, and start the following behavior. Here the feedback,
Mm-hmm.
total distance of the robot. And when the robot completes 6 meter, about 6 meter, it means that the robot make one lap. So the return result will the action will return the
Uh-huh.
result.
So there we see it going around it very close to the wall. And you said when it reaches 6 meters, right?
Yes, 6 meter about
All right, so where should be your... Oh,
and
there it
return
is.
the odometry.
And we can see the result of all of the points that the robot went through. Yeah?
Mhm.
Awesome. Great. So we saw your behavior on the real robot, which was really nice, amazing. So could you please just take a moment to explain how you
Mm.
solved each one of these three sections we have in this project?
Yes, okay. Let's go. I'll share PowerPoint presentation. Can you see the presentation?
No, we still see the construct dashboard.
Let's change the share the.
Yes, now we see a presentation.
Nice. Um, so let's start about it. The first section is about talks. In this section, I use two functions. One about the scan. Um, sorry, in this topic I use the just one function. It's about the scan talks. So I subscribe to scan talks, and every time I receive something from this topic, a function is called. And then in this function, I will process the laser data, and then control the robot via through the CMD view, this topic CMD view.
Mm-hmm.
To make robot to go ahead, turn left, turn right, and I will see the code. Let me stop this. Are you seeing the window from the construct?
No,
Or
we still see your presentation.
okay, I'll change. Hmm, okay.
Now,
Okay. So about the first section is in the all following.
mm-hmm.
Here in all following, I will start service client, then client action. And here I have the main following wall in this function, laser subscriber. In the laser subscriber, I will subscribe to scan, and every time I receive something from scan, I will call this function, laser callback, and in this function, laser callback, is the basically behavior of the all following. So how did I do to discover the beams of the laser in front of the robot, in the right of the robot? I used this code, these 4 lines, and then I received the raw range data from the laser, and I will get the shortest distance in this data ranges, and then I will discover the what is the bin of this shortest distance.
Mm-hmm.
So the shortest distance is mean distance, and its bins is mean index. So I will print this in the window, and then in the gazebo, I keep the robot turning left or turning right, and so I will see this distance in the window. In this way, I could discover which is the right beam, the front beam of the robot. Okay, with this, I make the behavior.
Mm.
The front of distance is shortest than half meter. It's mean there are something in front of the robot, so the robot will turn to left. If the right distance of the robot is higher than 30 centimeter, the robot will turn right to get nearest of the wall. If its distance, the right distance of the robot is shortest than 20, 20 centimeter, the robot will turn left to get away from the wall. Else the robot to go ahead. It is the main behavior of the first section. So in second section, let me share the window. Okay, so I printed the bins of the rope here. The 306 is front of the rope. 118 is in its right.
Yes.
Okay. And the second section about service. In the service, I use the two functions. One function is about a laser scan top. Every time I receive something, I will process the data from the laser to get the distance in front of the robot, to the right of the robot. And the second function is about the server service. When this server is called, it's start a function. In this function, I will identify the shortest distance and get this bin. I call the shortest bin. So if the shortest bin is higher than 360, it's mean the shortest distance is in the left of the robot. So the robot will turn left, turn left, turn left, until this bin is, while this bin is higher than 360,
Right.
the robot will turn left. So when the rope to front of this shortest distance, the rope to stop, go ahead, and then turn to the left until the shortest beam is higher, while shortest beam is higher than 270. Here I will show the code. Nice. Okay, it's then here we have the node about the server. And it start a service, find wall, subscribe to Scrum, and every time I receive something, this function is called. Just in the first section, just to get the dates from laser, to get the distance of the right of the robot, and that the 270 beam from the robot. And when this service, the server's find wall is called, this function will be called function handle find wall. In this function, it will see if the shortest distance is the left or to the right of the robot. If the shortest beam is higher than 360, it means the shortest distance is in the left of the robot. Else, it means the shortest distance is in the right of the robot. So the robot will turn left or right until the robot is front of the wall. Then we'll stop the robot, stop to turn the robot, and go ahead the robot until the front of distance of the robot is shortest than 30 centimeter. Then it will stop the robot again, and we rotate the robot uh, until the ray of the laser 270 is pointing to the wall. And then we return it to, and it is about the second section. Okay,
Mm-hmm.
let's do the last section. Let me share the window. And the last section is about action. In this action server, um, I have a function, two functions. A function is to get position and calculate distance from the odon topic,
Yeah.
and the last function is when the server action is called from a client with the go message. And then in this function, feedback will be published every 1 second. And when this distance is higher than 6 meters, the function will return a result.
Which
Okay.
is what we saw in the real robot.
I
Yeah.
will show you the window uh, here. Hold on record. Here I show this class. Hold on record. I create it created a record on action.
Mm-hmm.
Subscribe to Odon, and every time something is published in this topic, Odon topic, this function is called. And in this function, I get the position and calculate the distance of the robot. Okay, and when I receive and when this action is called, uh, this function is called execute. In this function, um, the action will be publish a feedback every 1 second with the distance, the total distance of the robot. And if the distance is higher than 6 meters, it means the robot completed 1 lap. And then the action will publish the result and publish a success message. And that's it. It is the node of the action, and everything will in is being called from a client, and the node the first node. Uh, Let me see the name of this node. I forgot. Okay. While following node, the first
Mm-hmm.
node. This node, the client will call the service and also the action. Okay, and that's it.
Awesome. Awesome, Marcos. Very, very nice explanation. Um,
Thanks.
very clear, and we really understood what each separate section was in order to achieve that behavior. So I just want to congratulate you, Marcos. I really liked a couple things, how you kept it simple and with information to know, for example, at the 6 meter mark to turn it off and return the result. That was really nice. I also really liked how you organized your uh, your notes in when with a good Python class that you can organize everything to keep a good structure of your code. That was really nice. One suggestion I would give you, Marcos, would be to try and limit. You did a good job, but try and limit the um, sensor callbacks, right? So you have a scan callback and an autumn callback, which is reacting every time you receive a new message from the robot. To try and keep those functions the smallest possible, and not process too much information, because you might lose the next message while you're processing the previous. So you won't find a problem here, but it's a good practice to have to eventually not have issues with lost or dropped messages, because that callback is still going. So that would be my suggestion. But other than that, Marcos, a very, very nice project. Really, really nice seeing this.
Nice.
All right, guys. So that's everyone for everything for us for becoming a ROS developer. So remember, if you want to do what Marcos did here, make sure to take our online courses and present your real robot project on a real robot. So then you can obtain a certificate from us for this online course. So thank you everyone for watching, and we'll see you next time for the next presentation. Bye-bye.
Bye. See you next.
All right, Marcos, good.